everyone, welcome to this video on the benefits, limits, and more about test-driven development as we kind of make it fit into the idea of DevOps. So as we explore more about DevOps and what it means, our ideas of test-driven development kind of, maybe we're not sure where they fit in the puzzle yet. So in this video, we're going to talk about some concrete benefits of test-driven development, because if you've watched the first video where I talked about kind of what it is and how it works, maybe you're feeling a little apprehensive about, can I do this? Do I understand how to do this? Why would I do this? It seems really unnecessary. So it really has kind of some more to it beyond just more tests. And then describing some kind of genuine limits of test-driven development and maybe when it's not an okay idea to apply it to your application or to your project. Where it fits in the testing pyramid, as well as kind of connecting those dots of our continuous integration, continuous delivery pipelines, and then this concept of shifting left, what that means, and how our concept of test-driven development kind of embodies shifting left. So we're going to start with benefits. Maybe, again, we're feeling a little apprehensive, and it's not just a testing technique. It really changes how we think about designing code and then how confidently we can ship. So with test-driven development, one of our first benefits is that it forces better design. Because when we write the test first, we're forced to think about the interface before the implementation. And when we say think about the interface, right, how the caller uses the method, right? What parameters does it take? What does it return? And code that's hard to test is usually code that's poorly designed. It has too many dependencies, too many responsibilities, it's too tightly coupled. And if writing the test is awkward, that's a signal that the design needs work. So before we've written a single line of implementation, it really tells us, hey, are we doing the right thing? And in that previous video, hopefully you've watched that, the FizzBuzz example that I used really illustrates this, because if you knew the function signature before writing a line of implementation, it's because the test defined it. And so we can compare test first versus test after, and this idea that if we test after, we write the implementation, then we write the tests that fit around it, and sometimes that forces awkward tests because the code was not designed to be testable. So if we write the test first and write the simplest code that satisfies it, the design emerges from the tests. You kind of discover it as you refactor. So the next benefit, or really benefits 2 and 3. So benefit 2, right? Test-driven development produces kind of a safety net for that refactoring step. So by the time you've completed several of your iterations, you have a comprehensive test suite that was built incrementally alongside the code. And so that means every refactor is immediately verified. If you break something, the test goes red. You can aggressively simplify and improve code without fear. And this is really kind of the promise of what test-driven development is trying to fulfill. You can't refactor safely without tests, and test-driven development builds those tests as a side effect of development. And then the third thing here is that it reduces our debugging time. So when we write code in small increments with a test verifying each step, the feedback loop that we use is measured in seconds and not hours. We don't have to worry that we've spent a bunch of time and now my test doesn't pass and now I have to go find out why. When a test fails, you know exactly what you just changed because you wrote it 30 seconds ago. And so when we compare that to that idea of traditional development, we can write 200 lines, run the app, something's wrong, now debug 200 lines to find where, and it all just kind of wears you down. So Studies of test-driven development and its adoption consistently show a 15 to 35% reduction in defect density at the cost of a 15 to 35% increase in development time. So it's really a net positive. The debugging time saved more than compensates for the fact that, you're going to make better code. That's really what it's about. So yeah, if you've been feeling a little like, I don't know about this, give it a shot. See what you think. Try a different mindset of writing code, and maybe you'll find yourself a willing proponent, a champion for test-driven development. So let's shift gears here for a second and talk about this concept of the testing pyramid, because there's this idea of a pyramid-shaped test suite that runs in seconds in our continuous integration pipeline. An inverted pyramid, where we have a lot of these end-to-end tests and fewer unit tests, runs in minutes or hours, and that means teams ultimately stop running it. So in our testing pyramid, we have our unit tests at the bottom. That's our test-driven development. We have a lot of tests. They're fast. They're cheap. We've got them very focused, and that's why it's the base of the pyramid. Those tests, the tests isolated by behavior, and they're focused, right? One behavior per test, and they're generally very comprehensive. That's why there's so many of them. Each behavior is test-driven. Then this feeds into our integration tests. So these are typically written after the fact. Test-driven development for integration tests is possible, but it's much, much harder. And so that's just generally not the way it works. So those are in our later weeks. And then we move into our end-to-end, that's E2E, end-to-end tests. And these are slower, more expensive. They test the full system. They test the full workflow. So yeah, that's where I said that inverted pyramid is going to run in minutes or hours. Teams stop running them. And a test-driven development process naturally produces these pyramid-shaped suites because it's the easiest and fastest to apply at the unit level, and each of our iterations adds a focused unit test. And so integration and end-to-end tests are added deliberately on top, but they are slower and they're more expensive. So as we move forward into our exploration of our different types of tests and how they work together, we'll see more of this pyramid. So where does it fit in kind of our whole pipeline of things that we've talked about so far, and this concept of shifting left? So when a software developer, especially an experienced one who has many years of building test suites under their belt, says something about shifting left, what they mean is that in traditional software development, testing happened at the end, after all of the development was complete. Shifting left means we're moving that testing earlier in the process. So if we think of everything as a left to right kind of iteration cycle, we're moving it down to the left, ideally making it part of the development act itself. So test-driven development is the ultimate shift left. A test is written before a single line of implementation, which moves tests all the way to the front or the furthest left side, as you can see here in the diagram. So how does this work with our continuous integration? Well, when we practice test-driven development, every small increment of code has a corresponding test, and when we push that code like into GitHub or another source control repo, the continuous integration pipeline that you will have set up runs those tests immediately. And that means your continuous integration pipeline validates each change against a suite that was built alongside the code and not just bolted on at the end. And so this feedback loop where we write the test, watch it fail, write the code, watch it pass, right? When we compare that to write the code, write the tests, push, CI runs the tests, it's red for 3 hours, then we debug, we fix, we push, and we go green. That first iteration, that first loop, keeps the continuous integration pipeline green continuously, whereas the second one creates the kind of fixing the build culture where a red CI is pretty normal and stressful. So in your team project, right, your test suite kind of grew organically as you were building out unit tests. But when you start to wire up your continuous integration pipeline, you'll push code and see immediate feedback with every pull request. And so the kind of investment in test-driven development now directly reduces the number of times your pipeline is going to break. All right, limits. Like all good things, it's not applicable all the time. So we're going to talk about some genuine limits of test-driven development and maybe when it's not worth pursuing. So test-driven development is harder for some types of code. It works best for code with clear, deterministic inputs and outputs. If you have strong business logic, validation and calculations, those are excellent fits. If it's infrastructure code, database connections, file IOs, network calls, that can be pretty difficult. It requires mocking and faking dependencies, which we will get into as we proceed in our lessons. UI code is very difficult. UI behavior is really hard to test at the unit level, and so you almost never see this unless the people don't know what they're doing. Or if you are using exploratory or prototyping code. At this point, if you're prototyping, test-driven development is going to slow you down because you don't actually know what you're building. And so there's a big difference between we don't have implementation yet, so we're going to build a test and then build the implementation for it, versus I don't even know what I'm building. What is this implementation even doing? How do you test for that? You really can't. So there are kind of limits to when you should choose to use test-driven development to make your life easier, or if you're just going to struggle with it. It doesn't eliminate the need for other testing either. It's not like I'm using test-driven development so I don't need some of these other tests. A comprehensive test suite of unit tests isn't going to tell you if components work together correctly, that's an integration test, whether the whole system behaves correctly end-to-end, that's an end-to-end test, whether the system is fast enough, that's a performance test, or whether the system is secure, that's a security test. And you can see we're going to cover those more as we proceed. But test-driven development is a foundation, right? It's a tool. It's not a complete strategy. And so, my kind of honest summary here. From the studies, we know that test-driven development increases upfront investment, right? You write tests as you go rather than at the end. It does reduce debugging time significantly, and it does produce better designed code. It is more valuable for business logic and least valuable for those things that we said where it's not appropriate: infrastructure, UI, prototyping. So applied selectively and well, it is one of the most effective practices in professional software development, but it does take a mind shift because it is desperately hard to teach people software development with a test-driven development first mindset. You kind of need to understand how to program first, and then we can introduce this concept instead of, if your intro to programming very first exploration class taught test-driven development, you probably would have given up. It would have felt very, very frustrating. So let's wrap up this video. Some key takeaways. Test-driven development does a lot of things for us. It forces better design because we think about the interface before the implementation. It produces a safety net that makes refactoring safe. It sits at the base of the testing pyramid. We have our unit tests. They're fast. They're comprehensive, and it is the ultimate shift left, right? Testing isn't something you do after. It's something you do about how you develop. It is the process. So as we move forward, right, we think about the limits on how we can use test-driven development, and you get some practice in implementing this into code on your own. So as always, I hope you have enjoyed this video. Always ask questions, always reach out with any comments or things that you need clarification on. and I will see you in the next lesson. Thanks so much.